Our story begins over 4.6 billion years ago. Imagine a vast cloud of gas and dust drifting through the cosmos. This was the solar nebula, the birthplace of our sun and all the planets that orbit it. It was a chaotic place filled with the remnants of dead stars and the raw materials for new ones. Within this swirling cloud, a drama of cosmic proportions was about to unfold. Gravity, the architect of the universe, began to draw the gas and dust together. Slowly at first, then with increasing speed, the nebula contracted. As it did, it began to spin faster and faster like a figure skater pulling in their arms. At the heart of this cosmic whirlpool, something incredible was happening. The immense pressure and heat generated by the collapsing cloud was starting to fuse hydrogen atoms together, releasing unimaginable amounts of energy. A star was born, our sun. The newborn sun blazed with fierce energy, illuminating the surrounding disk of gas and dust. This disk, known as the protoplanetary disk, was the breeding ground for the planets. It was a chaotic and violent place, with particles of all sizes colliding and sticking together. Close to the sun, the intense heat vaporized most of the lighter elements, leaving behind mainly rocky material. Further out, beyond what we now call the frost line, temperatures were cooler. Here, ices of water, methane and ammonia could survive, mixing with the rocky debris. Within the protoplanetary disk, a cosmic dance was taking place. Driven by gravity and collisions, particles began to clump together, forming larger and larger objects. Over millions of years, these clumps grew from dust grains to pebbles, then to boulders, and eventually to objects the size of mountains. These mountain-sized objects, called planetesimals, were the building blocks of planets. They careened around the young sun, their paths crossing and colliding in a chaotic ballet. Most of these collisions were destructive, shattering the planetesimals back into smaller pieces. But some collisions were constructive. When two planetesimals of similar size and speed collided at just the right angle, they could stick together, their gravity pulling them into a single larger object. Over time, these larger objects attracted more and more planetesimals, growing ever larger and more massive. In the inner solar system, where the sun's heat kept things toasty, rocky planetesimals coalesced to form the terrestrial planets Mercury, Venus, Earth, and Mars. These planets were relatively small and dense, composed primarily of rock and metal. The early Earth was a very different place than the planet we know today. It was a hot, molten ball of rock and metal, constantly bombarded by asteroids and comets, left over from the solar system's formation. This constant bombardment generated immense heat, keeping the Earth's surface in a molten state. Deep within this fiery inferno, a process called differentiation was taking place. The heavier elements, like iron and nickel, sank towards the center of the Earth, pulled by gravity. These elements formed the Earth's core, a dense metallic sphere at the planet's heart. Lighter elements, like silicon, oxygen, and aluminum, rose to the surface, forming the Earth's mantle, a thick layer of molten rock. As the Earth cooled over millions of years, the outermost layer of the mantle solidified, forming the Earth's crust, the solid rocky surface we live on today. The early solar system was a cosmic shooting gallery. Countless asteroids and comets, remnants of the planet-forming process, zipped through space, many colliding with the young planets. This period, known as the Late Heavy Bombardment, played a crucial role in shaping the Earth we know today. The impacts of these asteroids and comets were incredibly destructive, releasing enormous amounts of energy and blasting out huge craters on the Earth's surface. But these impacts also delivered something precious to our planet: water and other volatile compounds. Scientists believe that many asteroids and comets, especially those originating from the outer solar system, contained significant amounts of ice. When these icy bodies slammed into Earth, they vaporized, releasing water vapor into the atmosphere. Over millions of years, this water vapor condensed and fell as rain, filling the first oceans. The early Earth's surface was a hellscape. Volcanoes erupted with ferocious power, spewing lava and gases into the atmosphere. Vast plains of molten rock stretched across the landscape, punctuated by towering volcanoes and impact craters. These early volcanoes played a crucial role in shaping the Earth's atmosphere. They released enormous amounts of gases, including water vapor, carbon dioxide, nitrogen, and sulfur dioxide, into the air. These gases formed the Earth's first atmosphere, a thick, toxic blanket that trapped heat and kept the planet warm. As the Earth continued to cool, the frequency and intensity of volcanic eruptions gradually decreased. The surface of the planet solidified, forming the first continents. Rainwater, which had previously evaporated as soon as it hit the hot ground, began to accumulate in lower-lying areas, forming the first seas and oceans. Section 7. A breathable atmosphere. The early Earth's atmosphere was toxic to life as we know it. It was thick with carbon dioxide, nitrogen, and other gases, but it lacked free oxygen. This was about to change thanks to the emergence of a new life form, cyanobacteria. Cyanobacteria, also known as blue-green algae, were among the first organisms to evolve on Earth. These tiny organisms possessed a remarkable ability. They could perform photosynthesis. Using sunlight as their energy source, they converted carbon dioxide and water into sugars, releasing oxygen as a byproduct. Over billions of years, cyanobacteria released vast amounts of oxygen into the atmosphere. This oxygen gradually transformed the Earth's atmosphere from a toxic soup into the breathable air we enjoy today. The rise of oxygen paved the way for the evolution of more complex life forms, including eventually us. Section 8. The blue planet emerges. As the Earth cooled and its atmosphere transformed, our planet began to resemble the blue marble we know and love today. The continents, once scattered pieces of land, slowly drifted across the surface, colliding and breaking apart over millions of years. The oceans, now filled with liquid water, teemed with life. From single-celled organisms to complex plants and animals, life flourished in the Earth's primordial seas. Over time, some of these organisms ventured onto land, adapting to their new environment and giving rise to the incredible diversity of life we see today. The Earth's story is one of constant change, from its fiery birth to the emergence of life and the evolution of our own species. Our planet has been shaped by a series of extraordinary events. Section 9. A cosmic miracle. The formation of Earth is a testament to the power of time, chance, and the fundamental laws of physics. From a swirling cloud of gas and dust, a solar system emerged, and within that system, a planet capable of supporting life arose. That we exist at all is a testament to the delicate balance of conditions that allowed our planet to form and thrive. Think about it, the size of our sun, the distance from Earth to the sun, the presence of water and other essential elements. Even slight variations in any of these factors could have resulted in a very different Earth, perhaps one hostile to life as we know it. The Earth is not merely a rock we inhabit. It is a living, breathing system, a complex web of interconnected processes that sustain life. The air we breathe, the water we drink, the food we eat, all are products of this intricate system, a system billions of years in the making. From the vastness of space, Earth appears as a pale blue dot, a tiny oasis of life in a cosmic desert. It is a humbling perspective, one that reminds us of our planet's preciousness and fragility. As the only known planet in the universe that harbors life, Earth is a cosmic miracle, a testament to the universe's capacity for wonder and awe. As we explore the cosmos and search for signs of life beyond our planet, we must remember the lessons of Earth's formation. Life, it seems, is a rare and precious phenomenon, a product of a unique set of circumstances that may not be easily replicated elsewhere. Let us cherish our pale blue dot, for it is the only home we know.